Alright, so this video, what we're going to talk about is we're going to talk about naming with polyatomic ions. And there should not be a question mark there. Just a statement. Okay. Okay, so poly, you guys all know this from math class. Poly means many, okay? So if you have a polygon, it has many sides. So a polyatomic ion, poly meaning many, atomic meaning atoms. So many atoms, and this is an ion, which means it's going to have a charge, so it's gained or lost electrons. So two or more atoms with a charge. You will always have this. This is your star chart, okay? So this is your star chart. You will always have these available for you for any test. So you don't have to guess what they are. But I'm going to give you a couple of helpful hints, okay? If you see a compound that says something like, let's say you have calcium nitrate, okay? You're going to look at the endings of all of these compounds, and the ending is going to tell you whether or not it's a polyatomic or if you need to look at your periodic table. Alright, so let's go with a couple of rules. So number one, if it ends in IDE, you're going to look on your periodic table. So you're going to look on your periodic table, okay? That's going to tell you, so anything that ends in IDE is an element on your periodic table, which means it's going to be probably one of your non-metals on the periodic table, okay? So, number two, if it ends in ITE or ATE, okay? So either one of these two, you're going to look on your polyatomic ion chart. Okay, and so that's an R. And so this is going to be provided for you every single time. Okay, right there. And so most of these, we only have one of them that's positive. So most, we're going to say, are anions. And then you only have one cation. And so your one cation is going to be ammonium. Okay, all of the rest of these are going to be anions, so we're going to look at your endings for these, okay? Now, if you look, there's a couple of them. So let me go with another color here. Let's go with a green, okay? There's cyanide in here. So cyanide right here. It does end in IDE, but there's nothing on your periodic table that's cyanide. There's no element cyanide, okay? But most of the rest of these that are on this chart, if you look at it, they're all going to end in ites or ates, okay? And so, alright, so let's practice. So if I have a compound like, let's go with potassium nitrate. So the first thing I'm going to do is I'm going to look up potassium, and we know that potassium is going to be K. Now what's important is we still need to worry about oxidation states. So potassium we know is a 1+. Now we look here, and this ends in ATE, which means I have to look on my polyatomic ion chart. So I'm going to call it my pick, okay? So I'm going to look for my polyatomic ion chart, and so we're going to look for nitrate, and if you look, it's in O3, 1-, okay? And just in case, I'm just going to highlight where that came from. This is my nitrate right here, so it's nitrate ends in ATE. So the next thing that I need to do, okay, and you guys all remember this, right? I take this and I cross it down here, and I take this one and I cross it down there, and what I end up with is KNO3. So that would be my formula. Now, if I look at something like barium sulfate, so let's go to barium sulfate. This is going to be barium is Ba, group 2, so it's a 2+. Sulfate, so let's look over here. I see my sulfate. Sulfate is SO4 2-, and yeah, let me get the 2- on there. Okay, so it's SO4 2-, and again, how did I know to look there? Because remember, this ends in ATE, which means I have to look at my polyatomic ion chart. So now, simple thing is, I take my 2 and I cross it, I take my 2 and I cross it. Now, what I would end up with is a 2 and a 2, but because these are both the same charge, then I don't need to write them. All I'm going to write is BaSO4. So I can ignore the 2's because they're the same and they cancel out. All right. Now, let's look here at copper. So this is Cu. Remember this 2, okay, so this goes back to our transition metals. This is going to be a 2+. And then phosphate ends in ATE, so we're going to come over here and I find my phosphate. So this is going to be a PO3, sorry, let me erase that. PO4. And the charge on this is a 3-. So I take my 2, cross it, I take my 3, and I cross it. And what you would end up with is Cu3 PO4. Now here's what's really, really important. I need to put this in parentheses, okay? And then I'm going to put my 2 here. And the reason you want to put this in parentheses is because if you write it like this, Cu3 PO4 2, what you're saying is that you have 42 oxygens. But over here, what I'm saying is that I have 2 of these PO4 groups, and that's what you want to say. So what we want to remember is this is going to be wrong. Anytime you see a polyatomic ion, just go ahead, put it in parentheses, okay? All right, so let's go through a couple more examples. The first one we're going to do is magnesium. So we know that magnesium, we know this is Mg, and it's a 2+ because it's in group 2. Now we look at this back one, acetate. So I'm going to look over here. Here is acetate. And so the way we're going to write this is we're going to say C2H3O2. And so remember what I told you guys with these. When you see these, I want you to go ahead and I want you to put them in parentheses, okay? And then we know that the oxidation state for this one is a 1- as it tells us, okay? So you're going to take your 2, cross it. You're going to take your 1 and cross it, so that what we end up with is Mg C2 H3O2. Put this in parentheses, and then I want to put my 2 right outside there, okay? Alright, so the next one we have is iron 3. So remember, transition metal, this 3 is your oxidation state, 3+. Carbonate ends in ATE. So I'm looking over here at my polyatomic ion chart. I see that carbonate is a CO3 2-, so I'm going to write CO3 2-. Let's go ahead and put our polyatomic ion in parentheses, and let's go ahead and cross these. So we end up with Fe2 CO3 parentheses 3. Okay, and our last example here we have strontium. Strontium is Sr. Sorry, let's make this a little r because I would complain to you if you didn't do it right. So this is Sr 2+, and then we have cyanide. This ends in IDE, so normally I tell you to look at your periodic table. However, cyanide, okay, we don't have any element that's called cyanin or anything like this. So this is just one that you kind of have to know. Cyanide, which is why I'm showing it to you now. Cyanide is Cn, so we would write Cn, which is a 1-. So let's put it in parentheses. Let's cross them. And so we end up with Sr Cn2. Okay, so now we're going to look at some examples. So let's say that we're given the formula and we need to write down the name. Okay, so the first thing we're going to look at with this one is we know sodium. We know that this is a group 1 metal. And so we know that this 2 right here came from over here. Now, don't make the mistake of saying that this 7 came from there, okay? Because that 7 did not come from there. We know that sodium, okay, you guys all know this, right? That Na is a 1+, which means that this chromium here, this isn't going to have been a 1+. Sorry, this 7 didn't come from there. It's not a 1+. So we said that this chromium, this 2 came from the chromium, which is a 2-, right? This 7 did not come from sodium. We know sodium is a 1+, which means we didn't cross anything down there. That this is the actual polyatomic ion. And so if we come over here and we look, actually this should have a 2 right here. This is going to be dichromate. So the name of this would be sodium. Yeah, that's ugliness. Let me fix that. So this is sodium. Okay, and we know we don't need anything, no parentheses, none of that stuff because it's group 1 metal. So this is sodium, and then it's going to be dichromate. Okay. All right, now, next one. We have aluminum. We know this is in group 13, so we're just going to write aluminum. Okay, now, SO4, we see that there are multiple ions there, so we know it's a polyatomic ion. We're going to go to our chart, and remember, this 2 came from here. This 3 came from there. We don't write aluminum 3. We don't do this. This is wrong, okay? And the reason we don't do that is because, remember, we know that it's in group 13, so we don't need to write that. We know group 13 is a 3+ charge. So again, this aluminum was a 3+, and our sulfate was a 2-. So that this is our sulfate here, and so we just write aluminum sulfate, okay? And then let's go with calcium 3. You know what? I'm going to change this. Instead of calcium, let's change this to Fe. Okay, sorry about that. We're going to change that to Fe. So this is Fe3, PO4, 2-. Now, Fe we know is iron. Okay, we know that this 3, if we crossed it, so we're going to uncross it, came from the PO4. And we know that this 2, if we uncross it, had to have come from the Fe, which makes this Fe2+, this PO4 a 3-. And because it's a PO4, we know that there are multiple ions there. It's a polyatomic, so we're going to come over here and we're going to find that this is our phosphate. Now, the iron, because it is a transition metal, we need to say that this is iron. 2+ means that it's iron 2. So we're going to call this iron 2, and then we just add phosphate to the back of it. And that is it. That is how we name our polyatomic ions.